Okay, in the last session, we got to problem 96. Now we're in the home stretch now. If you made it this far, you certainly can finish it out. You're in the home stretch. So what I want to do is I want to do number 97. I do want to point out there's some SAGE code there for the students that are interested in practicing their SAGE code. You'll learn from that as well. So what I want to do is just simplify this. And again, for some students, they say, well, I can do this in my head. We would like you to put some work down. All right, so let's go through it. And to go through it, I'm just going to write down what I'm seeing on top. And what I see is I see a factorial. So it's 2n plus 2. I go down 1, 2n plus 1. I go down 1, that's 2n factorial. All right? Someone says, why'd you stop there? Why'd you keep going? You could, but I notice in the bottom, what do I see in the bottom? I see 2n factorial. What cancels off over here? These cancel off. And what are you left off with? Something fairly simple. And I'll write that down for you. You're left with 2n plus 2 times 2n plus 1. That's a fine answer. However, I do want to expand it. The reason for that is most people would expand that. Let's write that down. What do you get over there? 4n squared plus 2n plus 6n plus 2, which give me 4n squared plus 8n plus 2. Ooh, I think I made a mistake somewhere. Oh, I did. Now I see it. I'm sorry. I'm glad I made a mistake though, because I'll be honest with you, it's really easy to make mistakes. You're not thinking, you're talking, you're distracted, whatever. There's a mistake. And I want to point out what the mistake is. And the mistake is, 2n times 2n is 2n squared. That's fine. 2n times 1 is 2n. But I said 2n times 2 is 6n. It's not 6n, it's 4n. There's a mistake there. So I got to correct that. A little eraser out. And what's that? It's actually 6n. Sorry about that. Okay. There is code there for the students that want to look through that code. It's a SAGE stuff. We've been talking about that for some time. All right, let's look at number 98. I'm going to pull it aside. And it says find the arc length S, angle 135. We've seen these problems many times before. They tend to be a little bit confusing for students because they don't really remember what we're doing over here. S is the arc length. There is a measure on that, like it could be inches, feet, whatever. Radius is a measure. It's the radius of a circle, inches, feet, whatever. Theta must be in radian. All right, so now we have. They want me to find S. And what did they give me? They gave me the angle theta. Let me write this over here. Theta is 135 degrees. Well, I got to convert that. And the way we do that is pi over 180 degrees. Certainly degrees would cancel off. 45 degrees go into both of those, by the way. 3 pi over 4. All right, what's R? R is 5 inches. So 5 inches, that's R. Theta must be in radian. That's 3 pi over 4. And what would this give me? 15 pi over 4 inches. If you want, you can approximate that. I notice in the answer, they're not approximated, nor were you asked to approximate it. But if you look at that, I mean, if you took pi to be roughly 3, 45 divided by 4, you're looking at 11 point something, all right? But again, I'm just ballpark. I'm not saying that's the right answer. Use the calculator, you get a better answer, all right? So that's number 98. Let's do 99. All right, I'm looking at it. And what do I notice about this one? It says, find the first 5 terms of the recursively defined sequence. Well, they gave me the first term. It'd be tough to get that wrong. That's 15. All right, that's done. I want to write down A2 though. And I'm using this formula over here to do it. What is it equal to? 3 times A1 minus 2. Well, what's A1? A1 is 15. That's 45 minus 2, which is 43. All right, let's put down A3 now. What's A3? It's 3 times A2 minus 2. Well, what's A2? It's 43. What's 3 times 43? 129. What's 129 minus 2? 127. What's A4? It's 3 times A3 minus 2. What's A3? Well, it's 127. Again, they're getting more difficult. I hope you don't need a calculator yet. That's 300, 360, 381 minus 2, which is going to be 379. All right, let's do the next one, A5. Again, the arithmetic gets a little nasty, I know that. It's 3 times A4 minus 2. What's A4? It's 379. A little more complicated. Let's see, 3 times 300 is 900. 3 times 70 is 210. And 3 times 9 is 27. What do you get over here? Well, this would be 1110. That's a nasty number. Plus 25. What's that going to be? 1135. All right, you're doing pretty good. Let's go to the next page. Ah, that's a gift. Let's take a look at what the gift is. This is 100. And let's see. Find theta in degrees, and they say theta is between 0 and 90 degrees. All right, let's write this down. And yeah, certainly when I put things down, I'd have to know the cotangent. But I'm going to say I don't really like the cotangent all that much. I'd write this as tangent. But again, your mileage may vary. You may say, I like cotangent as much as I like tangent. They're really the same guy, by the way. And what's this going to look like? Well, if I looked at it, it would look like this. I'm kind of exaggerating it. Root 3 over 1. This would be theta. And what is that? That's a triangle I know, right? And what triangle is that? It's a 60-degree triangle. So what's theta? Theta is 60 degrees. Now, what do they want to do? They want an angle between 0 and 90. I found one, but they also want to write down the radian measure. Let me put that down for you. So theta is also 60 degrees times pi over 180 degrees, which is pi over 3. All right, let's go to 101 now. Okay, 101. I'm going to pull to the side. And let me see if I can do that. Sorry about that. And let's take a look. So I realize for some students it's very difficult to do. All right, they're looking to see the secant, they see the arcsine, and say, how could you possibly do that? And I'd say we've done these before, right? We want to write an algebraic statement down. So I'm going to say that I hope you realize the arcsine function, I'll draw a picture for you, is between, I'm just doing a sine function, it's between, minus 90 and 90 degrees. And what do we know about the secant there? It's always positive. And this is good news for me, all right? So let's write this down. And yeah, certainly, I'm going to just maybe use a triangle to do it. I'm not saying, I don't know what the triangle really is, the right triangle. I'm going to call this thing theta. The only thing I know about theta is I know the sine of theta is x minus 1, and this would be 1. So I got to figure out this side over here. But this is the part where it could get a little confusing. But I got to be honest with you, we really want to do the secant, and the secant's got to be positive. So this thing must be positive over here. All right, let's take a look at it. So what do you get? Pythagorean theorem. 1 squared equals x minus 1 squared plus, let me just call this something over here. I'm going to call this, I don't know, we'll call it y. That'll be y squared. But I know y has got to be greater than 0. It's a side, all right? I know that side's positive because the secant between minus 90 and 90 is positive, all right? So let's keep going. Let's get confusing, but let's put this down. 1, this would be x squared minus 2x plus 1, I'm sorry, plus y squared. Let me get my eraser out, it looks really bad. I'm going to solve for y squared now, right? And what would you get? 2x minus x squared. But again, remember y is positive. I didn't know that would y be plus or minus, but now I know what it is. And this side over here is going to be the root of 2x minus x squared. All right, now what do I want? The secant, right? It's going to be a ratio. So that's the reciprocal of cosine, right? So what's that going to be? The cosine would be, the adjacent over the hypotenuse. But now I got the hypotenuse over the adjacent. I have to copy that down. Bingo, got it. Go to 102. And 102 wants me to find the range of that function over there. Now this kind of reminds me of what you guys did in 119. This is a piecewise function. And I want to draw it. And someone says, why do you want to draw it? The main reason is so I can understand what I'm looking at. And if I know what I'm looking at, I probably could tell you what the range of it is. All right. So I'm going to say that it's really not bad to do. I'm going to draw the picture best I can. Whoops. Now I'm getting a little better at this. So I'm going to say, when x is greater than or equal to 0, I got a really simple root function. And that looks like this over here. All right, so I just did this portion. Now I got to do sine. And what does the sine look like? Well, it's only below the 0. So I want to point out the sine function would look like this. And if I continue in the other direction, it looks like this. But what am I doing to it? I'm stretching it out 3 units. So I'm going to put this over here. Steps down like this and comes up. And then it goes back up and back down. It does this forever in that direction. Question is, what's this point over here? And I really don't need to know the point. What I do need to know is how low does it go? And it goes to low -3. Then the question comes is, that's as low as it's ever going to go, but how high does it go? This thing goes up and up and up. Where's it going? It's going up forever towards infinity. So the range of this thing, -3, it touches it, and then it streams off to infinity. This is the range. Let's look at the K. All right, let's go to 103. And let's see if I got 103 on this page. Yep, I got it right here. All right. Now 103 is calculator, and I'm going to say that, I guess you need to trust me on this thing over here, but they want me to use my calculator. Yes, we want you to use a calculator, and you should be able to verify these numbers over here. Then you have to know the difference between degree and radian mode, though, right? If you're in radian mode, you would get -1.409. If you're in degree mode, you would get -80.751. You should learn how to use a calculator. Again, I know I say a lot to you. If you don't know how to use a calculator, please come by during office hours, and we'll be more than happy to help you. So again, these are also calculator exercises. Make sure you can do these on a calculator, whether you're using Sage or cell phone, or one of those really kind of dinosaur calculators that that people used to use a lot. They don't see them too much anymore because really cell phones have taken over. And make sure you can do this one over here on a calculator. All right, let's do number 104. And as I'm doing these things over here, I'm going to pull to the side. All right, just pull this over here. We'll look at the solution later. Give me a second over here. Well, I like this one because it just wants a solution between 0 and 2 pi. So what we normally do is we try to get the sine or the cosine of the tangent equals a number. And I think I can do that. So I'll write that down for you. I'm going to write down 2. Let me go back to the black. 2 sine x. Someone said, what'd you do there? I added sine x to both sides. And now I'm going to subtract √2 from both sides. And what do you get? Sine x equals -√2 over 2. Now, a lot of students don't recognize that number. So what I want to do is I want to try to recognize that from what we've done in the past. And so I'm going to put this over here. Multiply top minus by √2. And I'm rationalizing the top because it looks more familiar to me. And what do you get over there? You get -2 on top, and you would get 2 √2 on bottom. And what do I get? -1 over √2. So now I definitely know the reference angle. It's a 45-degree reference because it's the ratio is 1 over √2. But I'm still going to do the same thing I've always done. and that is draw one cycle of the sine function. And I'm going to talk about where that is. And that's minus 1 over root 2, which is over here. It hits it twice. And someone says, where did it hit it? And these are divided up into really nice equal pieces. It hit it between 180 and 270. Yes, I'm speaking in degrees, and between 270 and 360. So if the reference angle, I'll put this over here, is 45 degrees, my question is, what's the angle? And the angle is between 180 and 270, but as a reference of 45. So what's it going to be? 225 degrees. The other one, and again, they just want me to go between 0 and 360 degrees. We'll get this in radian later. Is between 270 and 360 with a reference of 45. So that'll be 315 degrees. All right, let me convert these to radian measure. And 225 is a multiple of 45. And how many is it going to be? 1, 2, 3, 4, 5. So it's 5 pi over 4. And this one over here is going to be, let's see, 1, 2, 3, 4, 5, 6, 7 pi over 4. The mistakes happen. This is why we want to provide a key for you. And if you look at the k, 5 pi over 4, 7 pi over 4. It's pretty good. All right, let's do the next one. This is going to be b. And I guess deja vu all over again. Just give me a second. I'll blow this out. And let's take a look, see if we can do it. I'm going to use a zero product rule. It's just between 0 and 2 pi, but I still speak in degrees. And what's it going to be? 2 sine. Sine. If this is going to work, it has to work with those numbers. 1 and 1. When I say work, with your fingers. And I'm going to say minus, plus. Let's see if that works. What would you get? 2 sine squared. That's good. That worked out beautifully. Then you get minus 2 plus 1, which is minus 1 sine. Yeah, it worked beautifully. So I'm going to, one condition at a time, I want this to be 0. And the only way that could be 0 is if sine of x is equal to minus 1/2. Now the other guy, the only way this could be 0 is if the sine of x is equal to 1. And this was known as a zero product rule. Draw your picture. I'll put the picture down for you. It's a sine function, looks like this over here. And then the question comes is, I want to look for the line y equals 1. That hits right there. What's that angle? That's really simple. That angle is 90 degrees. That's certainly on this interval between 0 and 2 pi. Yes, I'm speaking in degrees. I know that. But that interval is 0 to 360 degrees. Let's do minus 1/2. That's over here somewhere. And it hits it twice. And again, I'm always saying the same thing. It's got to be somewhere. Where is it? It's between 180 and 270. And 270 and 360. All right. So I'm going to do the reference for you. And the reference, looking at it, I'll put the reference triangle down for you. 1, 2, root 3. And this would be 30 degrees. All right. So let's write this down. X is, well, the reference is 30, but it's between 180 and 270. So that makes it 210 degrees. Now, again, the reference is 30, and it's between 270 and 360, which would make it 330 degrees. I have to write this down in radian measure. And, if I put it in degrees, what do I get? I'll put it in order for you. 90 degrees, 210 degrees, and 330 degrees. Now, I want to be honest with you. These things were all multiples of 30 degrees. Let me put this over here for you. And 30 degrees, I'll put this down for you, pi over 180. And that would be pi over 6. All right. So the question is, what's 90 degrees? It's 3 times that. So it's pi over 2. We knew about that anyway. What's 210 degrees? It's going to be 7 times 30. So 7 pi over 6. We'll look at the key later. And 330 degrees is 11 times 30. So it's 11 pi over 6. All right, let's take a look. See how we did. All right. So I'm going to say, let's see, I got the 7 pi over 6. I got the 11 pi over 6. And I got the pi over 2. All right. Let's go to the next page. And we're on 105 now. And it's, it's getting too tedious here. There's a lot of repetition. And I always say repetition can be dangerous, but I will say one thing about repetition, you get some as a brain memory from it. But let's write this down. All right. The first thing I do is I'm just going to convert 7 pi over 2 to degree measure. And that's 7 times 90 degrees. Now, someone says, could you multiply that? Of course I could. But I got to be honest with you, I'm not interested. I'm interested in doing 7 90s. 1, 2, 3, 4, 5, 6, 7. I'm over here. All right, I'm over there. So I'm kind of hoping that I can evaluate the cosine of 7 pi over 2. All right. Now someone says, what is that? Well, that's coterminal with 270 degrees. And what's cosine of 270 degrees? You should know that, it's 0. All right, the next thing I want to do is talk about the invertible region of the cosine curve because we're talking about the arc cosine. Where is it equal to 0? Right there. What is that? 90 degrees. Now, by the way, I don't mind you saying 90 degrees, but I want to point out to you, they were speaking in radians, and it's polite to answer in radians. And what would that be? Pi over 2. All right, that's done. Let's go to 106. And I'll read it to you. It says, find the numerical coefficient of the term whose variable part is in the expansion. And this is the binomial theorem. You may not remember. Who knows? I think it's the last thing we talked about, though, wasn't it? Let's write this over here. So I'm going to write down x minus 2y to the 9th power. And I know there's some term here. I know it. I know there's a term over here that has something here. And what does it have in it? Well, it would have x to the 6. Let me write this over here. And it would have minus 2y. Well, let's see. I'm going to put the 6 on the outside because it really belongs there. Let me just back up. I'll write that down again for you. X to the 6th minus 2y to the 3rd power. Those sums have to be 9. And what goes over here? Well, I'm going to say 9. On the bottom, it could be either 6 or 3. Doesn't matter. There's 6 or 3. I'll put 6 down. All right. Now, would I get what they got? And I do. I get x6, y cubed. What's the number? That's what they're asking for. So let's write this down. And one thing at a time. So 9 factorial. I'm looking at the number now. 6 factorial. 3 factorial. And minus 2 cubed is going to be minus 8. We're looking for the number. They want the coefficient. That's the number. Let's take a look at it. And look at the 9 factorial. That's 9 times 8 times 7 times 6 factorial over 6 factorial times 3 times 2 times 1. What do you have here? Minus 8. All right, yeah, we should be able to do simple arithmetic. 6 factorial, whatever it is, it cancels off. Now here's the problem. 3 goes into 3 once, it goes into 9 3 times. 2 goes into 2 once, it goes into 8 4 times. Let's see if we can do that arithmetic. I do make mistakes sometimes. 12, that's what 3 times 4 is, times 7 times minus 8. Well, I'm going to keep doing it. That's going to be 12. 7 times minus 8, minus 56. I'm going to do the multiplication. And I know it's negative. I'll put this over here. Let's see. 10 times 56 is 560. And 2 times 56 is going to be 112. We'll look at the key later. What do you have there? Minus 672. Okay, let's keep going. And over here, wow, this looks tough. This says solve. All right, let's take a look at that. This looks like it might be really tough to do. But I gotta be honest with you, no such thing as tough. It's gotta be doable. Like, we don't give you impossible problems. I'm not saying you can't start a problem wrong, but if you do start a problem wrong, you should realize that if it's going up the wrong, tree, so to speak, try something different. Let's take a look at that. And I gotta be honest with you, the only way this could be true, because it says equal to 0, is if this is equal to 0, provided this was not simultaneously 0. Let's see if we can do that. And what are you going to get over here? I'll write this down. Sine 3x minus 2 is equal to 0. Sine 3x is equal to 2. Well, that's the form I want. So what I'm going to do, I'm going to draw a picture of a sine function. Sine function looks like this. What's the ratio look like? 2. Looks like this. It's never going to hit that curve. There's no real solution to this. All right, let's go to next page. Make sure I'm doing that right. Yep, the next page. And 108. Consider, okay, I'm going to consider it. What am I considering? X equals t. This is a parametric. And y equals t over 7. Now, my goal over here is I'm not opposed to you making tables, but I want to eliminate the parameter. And what would I see if I did that? Well, if x is equal to t, I'd pop it in over there. What do you get? Y equals x over 7. So this is more familiar to me. What I mean by that, I know that this is a line. How do you graph a line? 2 points. X is 0, y would be 0. What's next one? I would probably choose 7 for x. Why is that? It's easy for me. What's 7 divided by 7? 1. I'm going to graph it. 0, 0. And then I'd have 7, 1. I'm going to say it's over here somewhere. I'm going to draw my line through it. All right. It says graph it. I graphed it. Is my graph their graph? Well, I like to graph better, but it's really the same graph. Eliminate the parameter. I did that. Next thing says, what's, like, for example, what's the domain and range of it? Well, I'm looking at it. Domain and range is all real numbers. All right. Let's do 109. All right. And 109 says, give the standard form of the equation of a parabola with the given characteristics. Well, you know me, I'm going to draw a picture of it. I'm not trying to memorize much. I'm just want to, see if I can understand what they're giving me. So the vertex is -1 and then -3. And that vertex is right here. That's done. The directrix is x equals -6. Let me see if I can do that. I'm going to count over 1, 2, 3, 4, 5. Yep, I'll put the directrix down. So I want to look at it, and I think I know where the focus is now. And I want to tell you why I think that is, right? And again, I'll get to their question later. So I know the vertex, but now I want to do the directrix. Before I do that, I want to point out, what's the distance between this? Well, this is that -1, and this is that -6. So the distance is 5. So that means the focus is 5 units in. I'm going to put the focus down now. If you're 5 units in, I kind of ballpark it, but I would like to write that down for you. And the focus would be a point. And what's that point going to be? Well, the y-coordinate is going to be -3, right? And if you're at -1 and you want 5 units in, you would be at what number? 4. And what does this parabola look like? Well, I guess I should draw that in for you, right? I'm going to say something like this over here. I'm not doing a great job. And that's what my parabola looks like. So let's write this down. And I know the form of this parabola. And it's going to be y. I'll write this down for you. Y minus k squared 4p x minus h squared. Here's the deal though. They gave me the h and k. This is h, and that's k. Let's write that down now. Y minus a minus 3. I'll do the 4p later. And x plus 1. I'm sorry, I made a mistake. I just noticed it. Sorry about that. X minus a minus 1 is plus 1. All right, what's the p then? It's positive. And the p is equal to, well, it's a distance, right? The p is equal to 5. So what's 4 times 5? 20. All right, we're doing all right. Let's go to the next page. I think it's the very last problem. And this is like, I would love to see a problem like this in an exam. But it says, find the coterminal angle. Oh, yeah, maybe I should write this down. 17 pi over 3. And I'm going to do, 180 degrees over pi. I know the pi's cancel off, right? And what do you get over there? 17 times, well, let's see, 3 into 180, 60 degrees, right? And someone says, could you do the multiplication? And of course I can. But what I want to point out is it's some multiple of 60 degrees. So if I did this, I'm going to say that's 6 times 60 because that's 360. What's this? It's 12 times 60. You get the idea? 12 times 60. But I want to go 17. So I got to do 5 more. So I got to do 5 times 60 now. Let me repeat what I just did. 6 times 60. If I keep going, that's 12 times 60. But I want to go 17, so I got to go 5 more. What's 5 times 60? 300. Let me do that for you. 90, 180, 270. You get the idea? At this line over here, put black over here. I'm at 270, but I need to go to 300. So I have to go 30 degrees more, right? Whoops, I got right back here. So what's this angle over here? Well, if I looked at it, and there's many ways to write that angle down, but they want me to find the angle coterminal with that. And there's just an infinite number of them, but I want to get the smallest one possible. So I'm looking at that, and that would have to be minus 60 degrees. All right, looking at that. But someone could say, I want a different one. You could put down a different one. I'm not opposed to it. So I'm going to write this in radian measure because they spoke in radian. So what's it going to be? Pi over 180 degrees. This reduces to minus pi over 3. Okay, we're at the end. And again, if you paid attention that entire time, good for you. All right, it'll bode well for your future. You'll be able to move forward. And I'm not going to say life gets more difficult, but the courses will get more difficult, but they'll certainly become more interesting as you start to learn more and more mathematics. All right, so let me call it quits. And you guys are, again, ready for that final, but you'll get information on that, so don't worry about that.